chapter 12, we're going to be talking about circles. And in lesson 1, we're specifically going to review quite a bit of vocab. So I wanted to start out with the definition of a circle. It says, recall that a circle is the set of all points in a plane that are equidistant from a given point, called the center of the circle. A circle with a center C is called circle C, or they may use this symbol for circle C. Now, if you take a look down below, we have a diagram. We're going to review some of our vocab, a chord, secant, and a tangent. And a chord is defined as a segment. It's important. It's a segment whose endpoints lie on the circle. Okay, so you can see over here, I have my chord AB. The segments lie on the circle. I kind of think about it as a segment that fits perfectly within my circle. Now, the diameter of a circle is considered a chord because the endpoints are on the circle. Happens to be the longest chord possible. A secant, you can look here in my diagram, a secant is a line, so it goes on, and it intersects the circle at 2 points. So my secant is a line that goes all the way through, but it does intersect it in 2 places. A tangent is a line in the same plane as the circle, but it intersects the circle in exactly 1 point. Okay, my tangent line intersects only at 1 point. I like to think of the word tangent as just touching. And that place where that intersects the circle, they call that the point of tangency. So they're going to have you practice identifying some of those things, and you'll know that when you identify a chord or a tangent or a radius, that sometimes there's more than one option. I may not list all of them here today. If I look at my circle P and I'm wanting to identify a chord, I can identify my chord with endpoint on the circle would be segment QR or RQ. So I'm going to write it as so. Now sometimes you might see them identify like the segment ST as a chord, but the line ST as a secant. When I'm looking for my tangent, well, my tangent line intersecting once would be here. I can see that would be the line UV, where I'm going to remember to put my symbol on top. My radii. Radii means plural, more than one. So here I have a radii PQ I could use. I would also say that I could use PT or PS. All of those would be considered radii. My secant line going all the way through, well, this would have to be my line ST. I'm going to put the symbol on top. My diameter is segment ST, and like I said before, this is also a chord. My point of tangency here would be U. It's not asked, but U would be considered my point of tangency. A couple other terms or phrases I wanted to review. One, congruent circles. Well, we know a congruent circle are 2 circles that are the same size. Well, how do you determine that? Well, congruent circles also are going to have congruent radii. Okay, so my AC would be congruent to BD. Concentric circles, well, this is a diagram showing concentric circles. You can see they're not necessarily the same size, but they actually have the same center point. Concentric circles have the same center. Tangent circles, well, again, tangent means touching, so there are 2 circles that touch at 1 point. These circles are tangent here. These circles are also tangent. In example B, They ask us to find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. When I look for my circles graphed on the coordinate plane and they ask me for my radius for circle D, my radius for circle D, I can simply just count the units. 1, 2, 3. And so here we would just have a radius of 3. Circle C, well, 1 unit there, so R would equal 1. My point of tangency, where my two circles meet, here my point of tangency, well, we're going to look for the coordinates. I'm 2 units over and 1 unit down, so this would be the point 2, negative 1. The equation of my tangent line, well, my tangent line for both circles is this one right in here. Now, the equation for that, you might not quite remember, but this has a 0 slope. It crosses at y equals negative 1. This is my y-intercept. Now, if I had a 0 slope, we were doing y equals mx plus b. This may be kind of where we start from. In the end, we're going to say for our horizontal line that our equation is just y equals negative 1. If that line had been, if I wanted the equation of my line tangent here, this orange line, well, remember a vertical line, this is when my x values are all equal to negative 1. I have an undefined slope. The equation of this line would be x equals negative 1. So a vertical line always has x equal. Let me talk about a common tangent. A common tangent is a line that is tangent to 2 circles. So here, L is a common tangent, M is a common tangent. Same thing over here, Q or P, both common tangents, tangent to 2 circles. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. The converse of that is also true. So if you have something, if your line is drawn, your tangent line to your circle, what they're saying is that the way that it's going to meet our radius, it's going to meet at 90 degrees. Okay, let's take a look at example C. So the summit of Mount Everest is approximately 29,000 feet above sea level. What is the distance from the summit to the horizon to the nearest mile? The answer will be the length of an imaginary segment, EH, from the summit of Mount Everest to Earth's horizon. And our diagram's not necessarily drawn to scale. So I took this example from the textbook. You can see it's example 3. Now, it says the summit of Mount Everest is approximately 29,000 feet. What is the summit? The summit is the very tip, right? Here. Well, from Earth, then this would tell me that in here, this would be 29,000 feet. In order to find our missing value here, I can see, because this would be tangent, I have a 90-degree angle. I actually can use the Pythagorean theorem, but I'd have to think about what my hypotenuse would be. Now, we know that this given radius is 4,000 miles. If I'm going to work in miles, I'm going to want to take my 29,000 feet and convert that. 29,000 feet, if I wanted that in miles, I'm going to go ahead and divide by 5,280. And we would find that we get about 5.49 miles. So this little section in here is 5.49 miles. What does that mean for our hypotenuse? Well, My radius is 4,000, and so yeah, this is going to be 4,005.49 miles for a hypotenuse. Now I can go ahead and set up my Pythagorean theorem. And go ahead and solve. So we are going to take our 4,005.49 squared. We're going to subtract 4,000 squared. And then, of course, we need the square root of that answer. And we would find that we get about 209.6 miles. Now, it did say to the nearest mile, and so our EH is going to be about 210 miles. Finally, it says that if you have two segments that are tangent to a circle from the same external point, the segments are going to be congruent. So here I have a tangent at B, tangent at C, and they both come from my same external point. This AB is going to be equal to AC. So in example D, when they are asking me to find HG, they're wanting the length of the segment. I know that both are tangent, and so this is going to have to equal. GH is going to have to equal KH, or 4 plus 2a is going to have to equal 5a minus 32. Go ahead and solve there. I'm going to add 32, and I'm going to subtract 2a, and we would find out that 12 is equal to a. Now, 12 is not my answer. They're wanting the length of HG, so I'm going to go ahead and plug that in, and I would find that HG would equal 28 units. What would KH be? Well, this would also have to be 28 units. Those should be congruent. Okay, if you have further questions on this lesson, please feel free to stop in and see me.